Hello, everyone. Today I'll be talking about big data meets AI in the context of Cisco Data Intelligence Platform. My name is Mohammed Afzal, and I'm the lead architect for Cisco Data Intelligence Platform and part of Cisco Compute Business Unit. I'll be talking about Cisco Data Intelligence trend, how this industry is changing with respect to the data lake and with respect to the AI. Then I'll be talking about how big data is actually meeting with AI, how the technologies in the big data world or in the data lake is converging towards AI technologies. Then I'll be talking about what Cisco Data Intelligence Platform is. And then we'll be diving into MLOps and distributed deep learning on Cisco Data Intelligence Platform and what Cisco Data Intelligence Platform Phase 1 includes. We'll be talking about data intelligence trends. Today, influx of machine-generated data is changing the data's landscape. Data is growing to several petabytes. In fact, becoming a norm in many use cases. Let's take a look at this example of autonomous driving. These are one of the use cases where data is generated at a very high velocity. Just look at the sample size. This pilot exercise has been performed by several auto manufacturers who are exploring autonomous driving features, and also by IT companies looking to offer solution to our industry. For example, 100 cars can generate 1.2 to 2 terabyte per hour. Here, what we are saying, roughly speaking, on the average, same sample size can produce up to 1 petabyte in 5 hours. Or you can say about 2 to 3 days on the average, this can generate about 2 petabytes per day. If you look at this is massive data ingestion. If you can do a rough math on translating it into many, many cars that we see every day, you can think of, we're talking about a humongous amount of data that autonomous driving car use case can generate. Now, this data has to be processed. The data is generated, but extracting intelligence out of this data is important. Therefore, this particular use case runs thousands and thousands of training jobs with several million simulations and many, many inference instances. And our prediction, later, this requires to be stored in archival or creating a model registry. So this use case is just not limited to autonomous driving. Today, this type of massive data generation is now happening in many use cases and in various industries, such as genomics, fraud detection, sentiment analytics, natural language processing, image and voice recognition and detection, just to name a few. And then we need to store this information to an object store for archival or for tiering purposes. So what we have learned from the previous slide, how data is being generated at a very high rate and growing exponentially in many use cases. And it is also generated in various forms, whether we are talking about structured, semi-structured, or unstructured. And variety of data is also expanding, such as to images, video, and voice to extract intelligence. Later, this data has to be processed, where we historically used to have Lambda architecture, where batch, real-time layers, and serving layer were involved. And now we talk about cup architecture, which we can call it as Lambda reimagined or redefined, which is batch and real-time in a single technology. Now it is quite evident that IT leaders are finding ways how to maximize the ROI of their data lake and how to unlock the power of their data to its full potential, which should be fully aligned with business outcomes. That's where AI core technologies are gaining tremendous traction. IT leaders have awoken with the importance of AI. An AI mandate is one of their top priority. It is now very widely accepted among IT leaders that AI is a game-changing technology. Today, convergence of data lake with AI is becoming more relevant than ever before. Even if you look around us, Apple Siri is one of the examples. We live and breathe in those environments every day, where data lake and AI are working together and bringing disruptive continuous innovation. And this is just one example. There are many examples similar to that. What we have also observed for increasing speed of innovation, it is important to democratize data lake and AI, which simply means AI for everyone and everywhere. This is where containerization is playing an important role. Compute resources are very well allocated and managed with containerization, and it has proven over time. And containerization has become a de facto standard for many applications. Kubernetes is one of the de facto standard, and it's the most dominated in this container orchestration and automation platform, and offers the core for on-prem container cloud for enterprises. Kubernetes has a very rich open source ecosystem, and it is plugged in with the industry leaders. It's plugged in with the continuous innovation and allow convergence of many technologies to cater the next generation of data analytics. With containerizations, organization can now manage computing resources elastically, which means on demand, deploy application in microservices architecture, and run multiple versions of application, the same application for AI, ML, and deep learning workloads. What we have also observed, object store is also emerging as a new standard for storing data. It is particularly very efficient in dealing with a lot of small files. With a lot, I meant billions of files, such as tens of billions of files, even more. And since the way the variety of data is changing and the ingestion is coming in various forms, the data set now contains images. And big data or Hadoop has a limitation of number of files. So object stores actually has addressed this limitation. It can also be used for data tiering and archival for data catalog or model registry and so on. Now with all those, such as data lake, AI, compute, and object store, it is important to have a platform that offers an ecosystem-driven data strategy. This should be resilient enough to adapt with fast pace of innovation and modular enough to scale independently. Here I'll be talking about big data meets AI. I'll be touching upon some of the historical aspect of it, how our journey was so far, and how we are actually getting into this space where big data is actually converging towards AI. Hadoop has been around us for almost more than a decade. It has addressed many use cases and a lot of other projects like Hive, HBase, Kafka, Spark Streaming, Rangers. I'm just naming few of them join this ecosystem to even empower it to the next level. It was a great journey so far, and it solved a lot of enterprise problems. But with Hadoop 3.0, the game has totally changed, where the big data has started leveraging its capability to start leveraging AI technologies. And in order to do that, Hadoop 3.0 actually introduced support for many technologies that it actually requires to stage the AI. For example, GPU is very popular in running high performing and learning at a very high speed. And Docker containerization is also important to run multiple application or a distributed application. And deep learning with TensorFlow or PyTorch directly on Hadoop cluster is something that the data scientist would love to do it. And so the containerization, GPU scheduling is all the new technologies is starting to emerge. And this is the technology actually open up the plethora of work opportunities for actually building up even more technologies on top of that, which you'll be touching upon very briefly. So Hadoop 3.1 is something that actually changed the game where big data meets AI. And we have a CVD for that. Cisco already published a validated design around this architecture. And on the other hand, now we are seeing Spark. Spark 2.3 actually came in Kubernetes, and Kubernetes is also a containerization platform. So containerization orchestration platform, but Spark 3.0 again take it to the next level, in which a data scientist who now can have more option to do this natively within Apache Spark 3.0. They can now use GPU to run their machine learning job. This natural evolution of Apache Spark caters the new forms of compute. We had the CPU, and now in this case, we have GPU, which provides our customer more option to analyze their data in a more efficient and a speedy fashion. And other technologies that I'll be touching upon will be addressing some other use cases and joining this ecosystem. And we published the demo on this as well in the early part of this year. And we have this demo available for you in this GTC as well, which we actually showcase how NVIDIA GPUs, and we actually designed this in our lab with the support of NVIDIA, and just showcase how Spark 3.0 can actually leverage advanced resources and how you can run TensorFlow job within Spark executors. Spark 3.0 is going to be GA soon, so we will be able to see in production environment. Apache Submarine is another staggering and very impressive technology joined in the AI framework. And it took it to the one step further to introduce a fully orchestrated distributed deep learning framework. Uh, if you want to do any non-Spark specific distributed AI, Apache Submarine is something that actually caters your needs. With this, user can now spawn a distributed job pooling and can actually schedule GPU resources from across the cluster. It is available both for Kubernetes and Yarn. Both the cluster can actually allocate resources for Submarine. It is very well integrated with other ecosystems such as Apache Zeppelin. Apache Submarine Workbench is also in the pipeline for tech preview, which will launch notebooks, manage AI workflows, so on and so forth. This technology is currently in tech preview, but we have actually published a solution as a white paper in our community blog. Once it's become GA, then we will have a more precise solution for production environment. Ozone is another project that actually caters the object storage needs. It's actually integrated with our solution, what we are currently working with Cloudera. I'll be touching upon that in more detail. It's a highly scalable object store, which is actually can cater tens of billions of files and block. And it have a very good access control with on-wire encryption. It is actually HDFS with S3 compliant APIs. It addresses the multi-protocol, and it inherits a lot of powerful features of HDFS, such as data locality. You can deploy it side by side with HDFS on a shared storage disk. Highly available, cloud native, works in containerized environment like Yarn and Kubernetes. Now I'll be talking about Cisco Data Intelligence Platform and how it is related with all the talks that we have so far, changing landscape and the journey from Hadoop to Hadoop 3.0. And then we have containerization, the GPU, distributed deep learning. A lot of changes happen in a very short period of time. Cisco Data Intelligence Platform is a cloud scale architecture, which brings together as a single entity while also being able to scale independently to address the IT issues in the modern data center. This architecture allows for extremely fast data ingest, data engineering done at data lake, AI compute farm allowing for different types of AI frameworks and compute types, GPU, CPU to work on this data for further analytics. And you can also see we have storage tiers, which actually allows you to gradually retire your data, which has been worked on, or you can actually use it directly for many use cases onto a storage dense system with a lower dollar per terabyte, providing actually a better total cost of ownership for storing very large amount of data. And it can seamlessly scale. The architecture can scale to thousands and thousands of nodes with a single pane of glass management. And it is a disaggregated architecture. Compute and a data lake is actually decoupled. And you can actually scale each component independently without affecting others. And you can imagine that you have different forms of compute, and the management could be a nightmare. So it is managed by our Cisco Intersight, which is a single pane of glass management for all different kinds of computes involved, even the storage nodes involved in this architecture. Cisco Data Intelligence Platform is largely enabled by Hadoop 3.0, Kubernetes, and object store ecosystem that work together. Cisco Data Intelligence Platform is catering the needs for massive data ingest. We just talked about some use cases, as you can see, is actually designed and thoughtfully designed to cater those needs with heterogeneous data pipeline and converging into the data lake. So we have put in a lot of thoughts around designing it with respect to the performance, the storage capacity, so on and so forth. There are so many touch points. So Cisco Data Intelligence provide storage at exabyte scale with tiered approach. So it can manage a lot of use cases, and the scale factor is to the point where we just talk about the use cases where the data set size is growing. And it actually helps in accelerating AI with advanced resources, where we are working very closely with our partner NVIDIA, in which we are actually bringing out the workloads, which has the advanced AI resources such as GPU. Cisco Data Intelligence Platform is empowering various roles involved. I'll talk about the roles, how the role has been changing in this landscape: data scientist, data engineer. So Cisco Data Intelligence Platform empowers those roles for model development, for example, in data science, inferencing in a cloud native way, and for data engineering for their staging their data pipeline and data hygiene and so on and so forth, and the workflow. So enterprises today are dealing with several challenges, because of all of this um, technologies to talk to each other. Eventually, or slowly, infrastructure silos started to emerge within their environment, and which actually translate to architectural problems and makes operational uh, life very complex. And it eventually translates to the scope and limit the velocity of the innovation, eventually bottleneck the time to work into product development lifecycle. Extracting continuous intelligence, I emphasize more on continuous intelligence as data is changing at a very high velocity. Extracting continuous intelligence from data lake using AI ML techniques for innovation is a key for successful business outcome. This reminds me of a very famous McKinsey three horizon model of innovation. In Horizon One, where we talk about continuous innovation, the core business, how we can innovate our core business. And in Horizon Two, we take it to the next level, capturing new markets, customers, targets. And in Horizon Three, we talk about bringing new capabilities and respond to disruptive opportunities. The 21st century requires these horizons should not be bound, time bound, and sequential. It should be done at the same time. The businesses should respond to disruptive opportunities. Their innovation should be aligned with that, because their innovation might become irrelevant or obsolete if there is a huge gap between building the capabilities and the innovation, or change or exploring the new opportunities. Take an example of Uber or Airbnb or Lyft. Very short time period from innovation to time to market and creating disruptive opportunities. Cisco Data Intelligence Platform integrates state-of-the-art technologies and help in accelerating the velocity of innovation. By simply democratizing AI, helps in maximizing the ROI of your data lake. Cisco Data Intelligence Platform is a cloud scale infrastructure offering a very clear vision in becoming cloud native from on-prem to hybrid in the long run. In this slide, I'll be just covering, it shows our partner ecosystem, who we are working, as I mentioned earlier. Cisco Data Intelligence Platform is actually integrating a lot of state-of-the-art technologies. Cloudera is one of the partners that we are working on. NVIDIA is also one of our top partners, where we are addressing all the AI-specific use cases. And the data lake side, we have a Cloudera data platform, private cloud base, and CDP private cloud. So all of it is integrated in Cisco Data Intelligence Platform, fully supported solutions that we are working on. OpenShift is actually powering the Cloudera Data Platform private cloud. So OpenShift is actually a Kubernetes backend, sort of, and actually is providing you a cloud native development environment, and actually capable of actually creating multi-tenant service, self-service portal for cloud native application. So actually set the stage for your private clouds and actually improves and speed up your journey from cloud native on-prem to hybrid in the long run. And this AI compute farm is actually designed to cater for both for Yarn and the Kubernetes. So you can actually still provision Yarn specific workload. So Yarn can also orchestrate workload in the AI compute farm. And as I mentioned before, Yarn can also actually schedule advanced resources such as GPU. Yarn can also utilize containerization. So any Yarn specific workload can also be used inside AI compute farm with the NVIDIA GPU and utilizing the Docker containerization, fully integrated, and we have published a CVD for that, as I mentioned earlier. So let's touch upon, because Kubernetes is changing the world, and it's very exciting technology. As you can see that Kubernetes is integrated in Cloudera data platform, private cloud in the form of Red Hat OpenShift. So what we are going to get out of it is actually an exciting technology. It's bringing a lot of new capabilities. It's actually increasing our rate of innovation and not capping it in anywhere, and actually cater to the different personalities, how different personalities such as data science, data engineer can actually onboard their workloads. And also it actually removes environmental inconsistency, because we can have test dev and production environment. We need to have these environments not to work in silos. We should have a production from time to market or from test to production should be as agile as possible. It's actually adding a lot of observation and monitoring, higher granularity with different tools. A lot of tools can be integrated with it. I'll talk about it very briefly in the next slides. And application portability. You can package the application on-prem, you can port it anywhere you want it. And the hybrid aspect of it, of course, with respect to extending your on-prem to the hybrid cloud. And it actually improves the utilization of the overall infrastructure. Containers allow packaging of many and more tenants, and the resources are allocated into the container, consumed, and returned back to the cluster. So the resource utilization is much more uniform and enable infrastructure for better utilization. Here I'll be talking about MLOps on Cisco Data Intelligence Platform. MLOps is actually getting a lot of traction these days because there's a lot of complexity involved in terms of onboarding AI framework from launching to all the way to the production. AI initiative and organization are now gaining traction and is given, whether they are in incubation, test, or pilot, or ready for production. But this comes with complexity of how quickly and securely and efficiently you can move it to the production. If you look at traditional DevOps processes, they mostly deal with code changes. The ML projects are not that straightforward. They're dynamic in nature with respect to code. Model, for example, is just changing because the data is changing. You need to retrain. You need to create another model or inject the data back into the model. Sometimes you have learning, and that learning needs to be injected back to the model. And frequent data changes. That requires retraining, then package and release it on a continuous basis. So you can compare it's not classical DevOps, hence mounting a lot of operational challenges for enterprise and affecting the speed of innovation. Here I'm going to talk about the 3 Ps, the personas, the process, the platform. They need to talk to each other. The persona, data platforms are transforming, and different roles, as a result of that, different roles are actually joining this landscape, and they have different set of priorities. For example, a data scientist is more focused on model development, use the latest, greatest software, fine tune it, tweaking the layer or hyperparameters, and deciding the use of right activation function. Least interested in how to package, deploy, and monitor it going forward. So as a result, there is a clear, significant gap between pilot and production environment. And as you can see that, the production environment has other strict requirements, which data scientists sometimes do not look at, such as security, governance, and compliance. So as you can see, there's a cloud SDX layer, which actually bring in a lot of it out of the box and actually adding and catering those requirements once it goes into the production. Same is true with other personas, such as data engineers responsible for data pipelines, data analysts, or AI/ML architects. Organization today, not having a DevOps culture, eventually struggles in catering the needs of these distinct roles, resulting operational silos. Therefore, implementing automated processes is critical for agility. For example, DevOps, which emphasizes culture with collaboration among those roles and eliminates silos, remove duplication of efforts, and delivers value-driven approach. Now we talk about the third component, which is we talk about the processes, how it has to be done, the model training, packaging, deployment, serving, monitoring, so on and so forth. The third component, that should align all the process with business outcome and allow every role we just talked about to contribute. Cisco Data Intelligence Platform, that's where we actually design it to solve this problem by democratizing via common data lake, accessible from compute intensive farm along with advanced compute resources such as GPU. With Cloudera machine learning MLOps functionality, entire repeatable model training pipeline to model release can be implemented out of the box, giving full end-to-end machine learning lifecycle management. Not only that, with Cloudera SDX, we can enable holistic security, governance, and compliance across full data lifecycle. Using CML model cataloging and ML lifecycle lineage, enterprises can unlock their data's full potential at scale. Enterprises can detect model performance and drift over time, measure prediction accuracy, fine-tune and redeploy with ACE. All of it is integrated in Cisco Data Intelligence Platform. Broadly speaking, MLOps with Cisco Data Intelligence Platform is industrializing your AI. In a similar fashion, just like assembly line in Industrial Revolution. Here I'll be touching about the technologies that we have integrated in Cisco Data Intelligence Platform, Spark 3.0, which I talked about, the GPU enablement. Currently, Spark 3.0 is also bringing and addressing many other use cases, especially data processing ETL, rapid accelerator for Apache Spark, which actually gives you an end-to-end data science and analytics pipeline entirely on GPU. So we can actually accelerate our ETL utilizing rapid libraries. In many test cases, it has been determined that it can give you up to 4x to 5x performance just based on 200 gigabytes of data set, and that these test cases has been publicly published. And it's also actually accelerating the XGBoost libraries with the GPU, so which actually give you unmatched execution speed performance in XGBoost utilization if you look at it. Apache Submarine, we talked about that, is also technology that we are going to integrate within Cisco Data Intelligence Platform. AI with Cisco Data Intelligence Platform, just the discussion does not stop here. The inferencing aspect of it we did not cover in detail. Inferencing is another area that is actually gaining a lot more traction. And in fact, training is done, you retrain it, and then inferencing, you need to do it on a day-to-day basis. And we can actually do it with Cloudera machine learning, and also we are actually looking at Triton Inference Server from NVIDIA, which is a totally cloud-native way of implementing inferencing environment in your compute cluster. So it actually provision Triton Inference Server or a cluster of instances under a load balancer, and you can auto scale it as your requirement grows, and the GPU resources are assigned to it. So you can actually perform inferencing within those servers. This may have different flavors of GPU, and is also integrated with your AI model repository. It could be S3 or HDFS or data lake we just talked about. So different roles are coming, performing inferences. As you can see that the inference servers are catering their needs. And if they need any specific resource to run the inference, an inference server will provide it. It's available for CPU and GPU both. So in some cases, you don't need a GPU. It's a very unique and advanced resource. So leave it for other resource intensive job rather than utilizing it. So all kind of frameworks, whether TensorFlow, MXNet, PyTorch, Caffe, all of it, the inferencing can be performed using Triton Inference Server. You can perform A/B testing using those inference servers, or canary modeling, or so on and so forth. So here I'll be talking about how you can begin your digital transformation with Cisco Data Intelligence Platform. So digital transformation is very important, very critical, and is part of continuous innovation as well. And innovation using state-of-the-art technologies is something that we are actually trying to get into Cisco Data Intelligence Platform. We have a lot of pre-validated architecture around Cisco Data Intelligence Platform, fully supported when we say uh, pre-validated, and we have a very strong and big partner ecosystems. We are bringing a lot of latest technologies, integrating it, making sure that we are creating a production-grade solution for our customer. It is continuously plugged in with innovation pipeline from our partner, from our internal units that we are working on very closely, and not only just bringing out pre-validated solution, we actually make sure that the solution also address the performance issue. So we have published world-class performance. We have published more than 20 plus performance numbers around our data lake, and at various scale. We're talking about um, through TPCX, which is the industry standard and vendor agnostic in terms of like give you an opportunity to publish performance, and all the vendors actually publish their performance numbers. And Cisco, we recently have published Cisco Data Intelligence Platform performance number. They're the world-class #1 performance number, both in MapReduce and Spark. We have been on all the records in that. It actually also, we have proven linear scaling. As you scale, your performance does not deteriorate. It actually also increases as you scale. So we are the only one who has published a very large size scale performance number, such as 300 terabytes. And in Cisco Data Intelligence Platform, as we talked about earlier, you can independently scale storage and compute. It offers data tiering and centralized management. As you can see, that there's a lot of flavors with respect to compute, a lot of types we have in it. And the reason is that data lake needs different kind of compute, and compute farm needs a different kind of compute. So for example, GPU, CPU, maybe more memory rich, or maybe more core rich, and so on and so forth. On the storage side, we are looking at more disk richness and all that. But all of it has to talk over the network. So Cisco Data Intelligence Platform has been designed very intelligently to make sure that it offers almost uh, zero over subscription, or best performance with respect to no network bottlenecks between the compute and the data lake, or the compute and the S3, or the object storage. Again, we're almost getting finalizing our presentation for today. Cisco Data Intelligence Platform, actually, it's a cloud scale architecture. You can see that we can scale to thousands and thousands and thousands of nodes we're talking about. With Cisco ACI, we have published the solution brief, and it actually talks very intensively how you scale it to thousands of nodes. So the management is done by Cisco Intersight, end-to-end management, and you can actually as well within that. So single pane of glass management, time to value with respect to deployment, and configuration consistency, so it avoids and the configuration drifts. And you can actually scale it to thousands of nodes without oversubscribing your network. So which means is you actually consistently maintain your performance even if you grow. So that's what I mentioned, linear scaling. So when your nodes are growing, your network is also resilient enough to actually accommodate those scaling and does not compromise on oversubscription. So we have other solution also, Cisco Declaration for security. We have also going to integrate with App Dynamics, because containerization is bringing a lot of workloads. We are talking about, we have service mesh there, is also part of it. Qflow we are talking about. So all of this, we need a very application specific, very granular monitoring. Cisco App Dynamics is very excellent in those platforms. And also, you need to know if your training and simulations are comprised of thousands of containers, or is a microservice architecture. Which containers is struggling with the resources, which containers is not performing right, or anything happening. So that kind of visibility you need to have it. So integrating state-of-the-art technologies to give you that kind of capability to actually offer you a cloud scale platform, which can run thousands of applications, thousands of simulations, can manage exabytes of data, so on and so forth. With that, I'm going to encourage you to visit the following link. It has a lot of valuable collateral about solutions that we have published so far. Solution brief is actually talks about the ecosystem that we are working on, ISVs that we are working on. I mentioned some of them, and abundant amount of resources, how to deploy it in your environment, production grade environment, solution briefs, uh, deployment guide, design guide, so on and so forth. So Cisco Data Intelligence Platform is where big data meets artificial intelligence. Please visit those sites to learn more about Cisco Data Intelligence Platform. With that, I conclude this presentation. Thank you for watching.